Hey guys, today we have lesson 4.3 in which we're going to talk about like corresponding parts of similar figures, how that relates to dilations, and then also modeling with the Pythagorean theorem. These are a few things that are pretty implied already in what we've been doing, but I thought I'd just address them specifically in case there are any gaps in our understanding. So to start with, what does it mean when two figures are similar? We've all used that word before, but it actually is a pretty mathematical term in geometry. And it means that a shape has been dilated by a scale factor to become the other one. And that means that every side on that shape was multiplied by some scale factor, which we already know, right? And the key here is that every side has to be multiplied by the same exact factor, otherwise it's not a dilation and it won't be similar figures. Okay, multiplying the same number on every side keeps the proportions, and then that's also the reason that corresponding angles also stay the same. Okay, similar figures always will have the same exact angle measures, and again, this fully is because of the fact that every side was multiplied by the same factor. It's all a big proportional thing. All right, so let's just go ahead and take a look at what these corresponding pieces are in similar shapes. Okay, it doesn't always have to be triangles, just right now we're working with a lot of triangles, but it can really be anything. Okay, so if I'm looking at these two triangles and I ask myself, okay, well, what's the scale factor between these two? If this was the original and this is the new one, you would probably look at this and be like, 10 turns into 20, and 20 divided by 10 equals 2. That would mean 2 is the scale factor, right? You could have used any side pair. You could have said 12 divided by 6. You could have said 14 divided by 7. Okay, and that is you subconsciously matching corresponding sides, right? Because like side AB, right here, it corresponds with side DE in this triangle. Okay, so I'm going to write DE. Side BC, right here, corresponds with side EF. Right, those are the matching sides. All right, and my last side here, side AC, kind of an ugly line. All right, side AC matches with side DF because, DF is what you get once you scale AC by the zoom factor. All right, now that we've matched all of our corresponding sides, we can also match corresponding angles. Right here, angle A has one arc, and this angle D also has one arc, and that is how the picture tells you that those two angles are congruent. However, if you didn't know that, you could also look at which sides it's in between, right? Like angle A is between like the blue and the green sides, and so it has to match with the angle here that's between the blue and green sides as well. Okay, so hence I get angle D. This right here is an angle symbol, it's not an L. Okay, I'm going to put them on all of these whenever I'm talking about an angle. So next we have angle B, this one right here, has two arcs, and it's between blue and red. So here, we're going to match it to E. Okay, and lastly, angle C, we got the three arcs, and it's also between green and red. So here, F is between green and red. So we have angle F to go with angle C. All right, so just make sure you understand how to match corresponding pieces of similar figures. Okay, so next is modeling with the Pythagorean theorem. Again, this is not really anything different. It just is something I do want you to be exposed to because, we're used to just doing Pythagorean theorem on random triangles in space, but now you have to do a little bit of reading. So, all right. Here we have Wendy with her new monitor to help her work at home more efficiently. And the monitor has a diagonal length of 18. So I've labeled that here for you. This diagonal right here is 18. And it's 15 inches wide, so I've labeled that for you as well. What we want to know is how tall the monitor screen is, not including the base, right? So we don't care about this height right here. We just want to know what this is. We'll call that our x. So we want to use the Pythagorean theorem to help us figure that out. All right, so the first thing we want to do is go ahead and label all of our sides with what we think the a, b, and c should be. Okay, so the first one you always want to label is your c because that's the one that's picky. Now, this is obviously the longest side, and it's also the one across from the right angle. So that tells you that you should label your 18 with the c. Okay, after that, these two are a and b. Remember, it doesn't really matter which you label a and which you label b as long as you've labeled the longest side c. Okay, so now that I've done that, I can go ahead and plug things into my formula. So instead of a squared, I'll write x squared. If you left that a squared, I wouldn't really care. A variable is a variable, but since we have an x, I'm just going to put an x. Okay, b, our b is 15, so next is 15 squared. And then our c is 18, so 18 squared. Okay, if I ever tell you to set up the Pythagorean theorem, you have to make sure all your pieces are squared. Okay, the next thing I'm going to do is go ahead and actually square what can be squared. This one won't change, but 15 squared is 225. And 18 squared, I believe, is 324. All right, now that we've done this, we are ready to start solving for x. Okay, so our goal is to get x by itself. The best way we can start to do that is by subtracting this 225 from both sides so that it can move away from the x. So we end up with x squared on the left, and on the right we end up with 99, because 324 minus 225 is 99. All right, and now our last step. Remember, this is always the last step. In every Pythagorean theorem problem, you will always have to do this at the end. Okay, now we have a square root, whoops, we have a square, and we want to get rid of the square, right? We're not looking for x squared, we're looking for x. So to undo that, we're going to go ahead and square root both sides. And if you do square root of 99 in your calculator, you will get an answer of 9.95. Okay, so we can say that the height of the monitor, or the screen of it, is 9.95 inches. All right, and that is all. So whenever you're approaching a problem like this, make sure that you read very carefully to know where side lengths go. I might not always label them for you, but sometimes I will. So it's all just depending on the problem. All right, give the practice problems a try if you haven't already.